Hi, I'm Wechat Primary 6 from YUMIN Primary School. Let's look at all these that have been written. They have been from last lesson, whereas we start this example telling all of you what types of methods we can use. And this is the second method. But it might look as it is very complicated, very difficult. But be careful, this is the general form, the general method. You can use it to solve many types of these questions. But you just have to be careful what types of ways that you are using. For example, in this lesson, we're going to use another method by just changing it a little bit. All these different types of methods, you need to know how you are using them, when are you going to use them, and what types of conditions do we have for them. With all of these, you have to be very, very careful in every single step in case you accidentally wrote the wrong thing. But for these types of questions, they're actually very interesting. You can use many types of these methods. So we're going to use another method. And for this, okay, but this sigma is just a notation. You can use different variables. You can use different of these. You can use different ways of factorizing them. And using here is a differentiation and integration. You can have different ways of using them. Okay, so for this, we're going into the third method. So from this first step, I'm going to change it a bit. For the rest, I'm going to erase them. Okay, right now we are at our method number 3. We're just going to change this x to the power of I into x to the power of I plus 1. And again, since we're at this third method, I can explain more about this f. For this function, we let one of these functions. Well, but you have to be careful. We are let a general function, and inside this general function, your original example have to be included inside. With this general function, you actually are finding for a general way. So for this part, last lesson we used I, just because for this first part, we want to make it simpler. Okay, so the method that we are going to use is partial fractions. Still is partial fractions. So it's going to be like this. Then at this point, we can separate these two parts from one sigma into two of them. But at this part, we are still going to use differentiation and integration. Differentiation, well, we can remove this denominator. And then at that time, we can use the formula that we have for our geometric progression. Okay, so let's take a look. But here, you only need an I, but the power you have I plus 1. The power of I plus 1, it is actually x to the power of I, then times x. Is it right? Okay, yes. So this numerator, we can change it into x. Then this is x over 2. Then this part, sigma, I goes 1 to infinity. Then you have x to the power of I, then over I. Okay, so this part I can write it in front so that later we'll actually have space. For this is the first term, then for the second term, this denominator is I plus 2, but the power we only have I plus 1. So we'll need to times another x here. So here we need to divide an x. So it becomes 1 over 2x. Then sigma I from 1 to infinity. Then here is x to the power of I plus 2 over I plus 2. So what's next is to use differentiation. So we'll just differentiate for this part. But after you differentiate, you'll have to integrate. But let's see for this part. Which of them do we have to differentiate and which do we have to integrate? So we can just for these with sigma. So this boundary is 0 to x. We'll explain more of these in other lessons. So for this part, when you differentiate, sigma still stays the same. So here, x to the power of I, then over I. Differentiate, so this I is taken out. So it becomes x to the power of I minus 1. Then dx. This part at the back, minus 1 over 2x, then integrate 0 to x, sigma still stays the same. And here this power simplify with this again, so it becomes x to the power of I plus 1, then dx. Then on this part, what you can realize is this is a geometric. Well, it's just the sum of the terms in a geometric progression. These two, they're both the same, but it's just that the first term is different. So at this part, for this geometric progression with infinity terms, to find their sum is the first term over 1 minus their ratio. Their ratio is the second term over the first term, and they must have a common ratio. So for this is a 1, so you can just put dx up there over. So this is a 1 minus x, and minus 1 over 2x integrate from 0 to x. Then here, first term, x squared over 1 minus x dx. So after that, at this part, it is already, you can see that it's a ln. So here you have a negative x over 2 ln 1 minus x, then 0 and x. Then at this part, this x squared, you can plus 1 minus 1. So that you can separate them and simplify. So let me just write that step out. And then it will become, so x, you can sub it inside here. So then it becomes negative x over 2 ln 1 minus x. Then 0, sub it here, ln 1 is a 0. But ln 1 times x over 2 is still a 0. So behind is just 0. Then at this part, we can separate them from here. And then it will become so your minus 1 over 2x, then integrate from 0 to x. And then here it's, so x squared minus 1. You have an extra negative. Then you have, so for this part, now what happens? You have x plus 1, then plus 1 over 1 minus x dx. So this part you don't need. Then from here, the first term stay the same. And then for that second part, so x plus 1 over here, you can integrate. Actually, this part at the back, you also can integrate them already. So for that first, negative, negative, positive. Then you have x becomes half x squared. Then 1 becomes plus x. Then here you have to sub 0 to x. And then negative, negative, positive is a negative. But from here, because it's a negative x, so you have another negative. So there's a plus. Then what happens? So from this part, this would be a ln. But you'll still have 1 over 2x. So it becomes like this. First part for the next, still the same. Then second part. So x you sub in is still x. And you have, okay. So because that this is times an x, so you can write it in the numerator. Now that here x, it becomes plus half. And then 0 sub inside is just a 0. So then for this part at the back, what you'll have here is plus 1 over 2x ln 1 minus x. Then 0, you sub it inside here. Ln 1 is another 0. So this is still 0 for the second part. And then you get this. But this is just a general function. You need your special function. You need to get it back to our question or the example. But for this, you actually sub 1, x sub 1. So you can write it as f1. So just write it inside. So for this, when you're subbing 1, the first and last term, you'll have infinity, so you cannot sub in them straight away. But the two terms in the middle, you can combine them into 3 over 4. And then after that, those two terms, you put it into the limit. So you'll get x approaches to 1. Then at that part, you can try to factorize those that are common. For example, half ln 1 minus x. Then what's left is 1 over x. Then you have to minus an x. So for this part, you get common denominator. Common denominator, and you have 1 minus x squared. Then for this part, a squared minus b squared. And down here, this x, you can just straight away sub 1. Then ln 1 minus x. Then this part. So here you can sub 2. Then it will cancel out with this. But for this part inside, you'll realize here is a 0, here is infinity. So you get a 0 times infinity. Then 0 times infinity, you can put this 0, this 1 minus x, as a denominator of the denominator. So it is like this. And then after that, you'll find out that this part is now an infinity over infinity. X, it is continuous. Then this infinity. Now you're very sure that you can use the L'Hopital's rule. So up here, this negative 1, you have to be careful of it. So it will become negative 1 over 1 minus x, then over. So this part, you need to use the chain rule. So at first, this is a power of negative 1 in this denominator. Then you have another negative, so it's positive. After that, you need 1 minus x squared. And then like that, you can simplify. So this is a 3 over 4 minus limit x approaches to 1. Then bracket 1 minus x. Then at this part, you can sub it in and it becomes a 0. So now this part, you have 3 over 4. And so, now let me just tell you something. For this part, if you don't want to waste so much time, you could just let it be an s. So for this, you can say s, at last is still 3 over 4. But these methods, you have to be careful of them and you have to be aware of when you are using them. For example, you have to get this denominator and this numerator the same first before you can differentiate and integrate. And use the formula for finding a sum in a geometric progression with infinite terms. And then for all of these, well, of course, integration, you realize you have to use our basic formulae. Then for all of these, this power, we can change it. We can change it into many different ways so that we have many methods. But denominator, we can also change it. So in the next lesson, we might want to try when this power becomes I plus 2. And then for those other lessons, maybe you will try a different way for the denominator, and then a different way for the numerator, but at last, we'll be sure to show you a very, very simple method. So for all of these, letting this function. So for these parts, at last, you should still get 3 over 4 as the answer. If not, there might be something wrong with your method. Okay, so for this lesson, I think you can end it here. So if you like our videos, don't forget to subscribe to our channel. So we'll see you in the next lesson. And thank you for your watching.